It's been a little while since I've done an update. Got most of the cutting done of the chassis and the unibody, removed a lot of material. Got a lot of the structure that I'm going to have ultimately in the car back in place. So I thought it might be a good time to kind of show you guys what I've done so far. I've cut a lot of material away, kind of more than I thought. Now, didn't necessarily have to do that. There's actually a lot of room in the engine bay. But by removing the extra material, I was able to add structure in places that otherwise wouldn't be there, and then also hopefully make the car easier to work on. The motor now goes in and out like super easy, straight in, straight out, no tilting or anything like that. So let me show you a little bit about what I've done here and why I did it. Alright, we'll start at the back here, kind of looking down from the exhaust, if you will. So I've now removed all of this structure that was here and part of the floor. I still have part of the floor intact, but I removed most of the floor that was above the gearbox. It really wasn't doing anything. It makes it harder to attach, say, shifter cables and do the clutch slave cylinder and stuff like that. So cutting that out made a big difference in just accessibility of the motor and trans package. And then the big thing I did is cut out all this center here. This was a piece of sheet metal and then a huge brace. You can kind of see the original size and shape of this brace. I didn't necessarily have to remove all that. I could have cut a couple holes in it to do what I needed to do, but this allows me a lot more room to run the intake from the compressors to the intercooler, and then also obviously from the intercooler to the motor. It gave me more clearance. You can see it's not symmetrical. It's because the gearbox right here, you can see, is also not symmetrical. So that bend kind of clears this hump, and then all of the shift linkages right here, it kind of goes across like this, I think is how I'm running it. So this bend lets me clear all of that without any excessive bending. So you really want this tube to be straight. I mean, ideally, anytime you do a load, you want the load to go through a straight tube. That's where you'll see pretty much everything else I have is straight when possible. And that's also why these diagonals are so important, is at the bend is braced to the shock tower, braced on this side of the shock tower, and then of course all those tubes are smaller, but they're also straight. So that braces the bend and kind of creates it, helps stiffen that up. So you never want to bend unless you have to. I had to in this case, but I did the best I could to strengthen it. So the real deals that I had to do was the engine cradle and the strengthening of the chassis because of it. So the big problem you have is you have control arm right here. This is the lower control arm, and if you look kind of straight down, that load is going into the camera right now. So when I'm in a corner, in this case going right, the load comes through this and wants to go into the camera. Now you can see without all the metal I have here, this would just flex really easily. So the factory has a connector that goes from here to the other side here, which all that does is actually transfer the load from the left side to the right side, which is good. But now you have the whole thing, civil engineer, I think call it racking. Basically this wants to go this way and this wants to go this way. So the whole thing turns into a parallelogram instead of a rectangle, which is not good. Now ideally, you run an X from here up to this, and then from here up to that, and that would solve your problem. Now obviously you can't do that because the engine and transmission is there. That's why you'll hear a lot of motorsports about stressed engines, or the engine is a stressed member. That's literally what it does. So you'd have a bell housing or something here, a big billet chunk of aluminum that you have to have for the strength of the gearbox, and you'd run a brace into it from here and a brace from the top corner up into there, and now you'd have basically a triangulated box for the rear suspension, and the engine would be basically passing the loads through the engine or the bell housing or the trans axle or whatever's there. In my case, I can't do that. One, I want the engine to be completely rubber isolated for noise and vibration harshness. Two, the engine's not designed for that, although my billet mid plate probably could do that. Just wasn't able to. So the best scenario you could possibly have is you're trying to make a box as strong as you can. So think a six-sided box. Is you build your six-sided box with tubes, and then you have a diagonal across every side, every face, and then one going through the middle. Two on each side. If you have an X, is really the best way to do it. But really, you just need one going diagonal on each side, and then one through the middle. Well, what I've done is I've done the best I can to do that with this chassis. So obviously, there's nothing running through the middle of the engine, so there's no diagonal going through. So nothing we would do about that. But what I've done here, let me show you. So originally, the factory has a brace. Go to the front here, so you can see those 2 points right there and right there. Has this big U-shaped brace that goes down, those around under, and back up. And that's how they handle the whole not having a cross. It's a huge steel, well-designed actually brace that keeps that racking from occurring, so it can't kind of parallelogram on you. Now, I wanted to get rid of that for a couple of reasons. One, I had to get rid of it anyway. There's just no way to fit it with the transactional. I'd have to cut it a whole bunch. So also, you know, I have turbos mounted kind of in the corners there and there. I've got 3-inch exhaust, which the factory exhaust goes through the suspension, which I do not want to do. One, it's hard to get a 3-inch piece of tubing through there, and then also I really don't want a extremely hot piece of exhaust tubing running near my ABS wires, my brake lines, my shocks, etc. So that wasn't really an option for me. So I'd actually change the load, because if I had just gone from left to right and braced it, I would have actually a pretty filmy suspension. It would look cool, you know, it'd have, you know, what you like a strut tower brace looking thing on the bottom, but realistically, you just turn that whole thing to a parallelogram when I go into the corner. So what I did is I added this tube here. So what this does, you see this lines up with the lower control arm. It transfers the load straight, no bends, all the way over to here. And although not shown, is there's a 3/8 steel bracket I'm welding onto into that that'll bolt to here. So it's not there right now, but it will be. It slides into the tube and it'll get welded and bolted here. And then the plan is add another reinforcement to the bottom plate of this, and it'll be in double shear. So you can see this is the engine cross member, which I'll show you here in a second. 3/8 plate. Then this will connect here with another 3/8 plate, so you have a total of 6/8 material right here, 3/4. And then there's gonna be a plate welded at the bottom of this that goes across. That puts us all in double shear. And double shear means you have a U shape on either side, and that's the strongest way to do it. So basically I'm transferring all the load into this bulkhead of the chassis, which is very, very stiff. And this will probably end up, weld a plate on and probably bolt it so I can remove it and so I can drop all this stuff straight down. But basically what I've done is on both sides, and here's the other side. So here's that, you can see it goes straight into where the control arm is, and you follow it down, and it goes straight into this. So now we've got the loaded suspension being transferred straight into the chassis, which is what we want. And then of course we've got this X, so the whole thing doesn't want to flex in kind of this direction. So you can see we don't want it to go left or right, it won't bend inward, but also the whole rear of the chassis can't sway back and forth like this because of the X brace. Then we've done a little bit of bracing here at the back too. The toe arms are relatively low load. Matter of fact, in theory, if everything is perfect, there's basically no load in there. So it's not quite as extravagant bracing, but you see it's still triangulated, it's still really stiff, it's not going to be an issue. Another view kind of the mid-plate brace we've done here from the front. Try to get the light out of there, but and then kind of similar concept on the engine mount without the engine in it. You can see it's kind of triangulated, it's got all strength. The only thing that's not shown here that I will add once I'm kind of done, because I got to figure out how I want to run them. But this is the engine mount. So right now you have this huge lever. So you see this distance is a lever. So when you hit the brakes at 1G, which the car better do over 1G, this is want to go forward. Which is not good because there's obviously no way to support that. I've got all this triangulation, it's stiff left to right, but when I hit the brakes, all the load of the engine, which is heavy, you know, 700 pounds, maybe 600 pounds with the turbos and everything from here and here is going to go forward. It's going to bend that thing. I mean, there's no question. It looks strong, but there's no way in that direction it's going to hold up when I hit the brakes or, heaven forbid, get in an accident. So what I'm going to be doing is there's going to be a brace that'll bolt in so it's easy to remove the motor. That'll bolt. The engine mount had clamshells around this, so it'd be like a plate that goes in here that's attached to the motor. And the backside of this bolt, and it's a 1/2-inch bolt, and we're going to brace from here back to the chassis here. And so you can kind of see, and move the camera, it's kind of maybe 60 degrees back, so it's almost straight back. And I don't know where that actually is going to end up. It really depends on the turbo. So in theory, I could run it straight back to this, which would be even better. But it just depends on where the turbos go. So I'm waiting to do that. I'm waiting till I have the turbos mounted so I can figure out where that needs to route exactly. And it's kind of similar to what I've done on the transaxle mount. So again, same kind of thing. Transaxle mount doesn't need as much bracing. Sorry about that. Here you go. But here it is. And then, but I've added these. This is almost exactly what I'm going to do, just much bigger. This is like I think a 3/4-inch tube or 1/2-inch tube. And then the front's going to be 1-inch tube. It'll be much bigger. But you see double shear, that's what I was talking about earlier. That's what you call double shear there. And it bolts to here. This is all loose right now. But so that prevents, you know, the tranny from going forward. Same concept we'll be doing on the motor. It's really important. Otherwise, you got, like I said, you got this huge lever arm here, and that's like a 6-inch lever arm. So you got let's say 700-pound engine at a G1/2. What that's 1,050 pounds basically going forward. You can imagine 1,050 pounds way out there would bend and break that pretty easy. Obviously, it's all tack welded together. It's gonna be finish welded, but so that's what we did. So got all this stuff going on under the car. Let me show you inside the car because it all is related. So all this stuff under here wouldn't do us a lot of good if it wasn't tied into something inside the car. Because it's a system, it's not just a single plane. You can see all this is in one plane. We have a three-dimensional thing going on here. So I'll show you how the top works too. Alright, so now top view, better idea of what this all looks like. You can see the bracing from up here. Again, it's a system. Showed you kind of the horizontal plane, if you will, all this good stuff going on here. Obviously, we still have all the stock chassis rails, so they'll create part of the system. And because this is really what why a frame car is inferior to a unibody car in street car terms. Obviously, if you have a huge tube chassis, that's even better. But all this sheet metal is structural. So you have this tube, you can't really see it, but it's formed into the chassis. And you have all the sheet metal. That's like a unlimited number of diagonals. So this is really stiff in this plane. Same thing on this side. This is stiff. And I made this stiff, and I made the floor stiff. But there's a huge hole in the firewall now. Now I'm going to sheet metal all this up, obviously. Maybe another video go into the details. I'm going to do that. But all this will be sheet metaled up. And I'm going to do a firewall all the way to the roof. So this will not be a hole anymore, but it won't really be structural. So what I've done is I've run a tube diagonal again. You can see this rectangle going here, down here, and then across over there. It's rectangle, unsupported because there's a huge hole in the center and there's none of this here, and I cut all of that out. That's where the pulley goes. You can see that tube actually has a slight bend in it. The pulley actually pokes through right there, the crank pulley. And so what I've done is, now there's another plane that needs to be reinforced. So I've got the factory bar here. This is really thick steel, so that stayed. But they see this tube ties that tube into this cross tube. This cross tube goes left to right. And also it's tacked, you can see just barely kind of in the trans tunnel, but this will have a reinforcement plate around it, so it'll be tied in the trans tunnel and then tied in the center. So now I've got, now this whole area is stiff, it's triangulated, using this crossbar, and then of course the chassis itself is very strong up through here. So that's triangulated. I've got this back's all braced up, I've got the bottom braced up. So all I'm missing is the top and the middle. So this is all open, this is where the engine goes obviously. I'm going to end up doing a bolt-in X brace that goes from here, and of course on the other side matching, and it's going to go, say, from this side over the shock tower, that nut right there, and then same thing over here to over here. So then I'll have an X on the top of the car, which will stiffen it. Basically, I'll have every possible bracing done, like a race car would if it's a tube chassis, except for through the engine, which without a stressed engine you can't do. So this thing ought to be super stiff. All this is going to be hidden. What's really cool is all the interior stuff, you won't see any of this. You'll see the X brace, there'll be a window back here. I'll probably paint the color of the car, which will be blue or green. I haven't decided yet. But all of this behind a firewall. So the firewall is actually going to start just ahead of this and slip back. And you can see that this tube is way far back. It's in its diagonal plane because the firewall is going to go in that diagonal plane so that I have plenty of seat room. I'm 6'2", so I need all the space I can get. So the seat will back up to that firewall. It'll be, I said all this will be sheet metaled in, but that will not be structural. It'll be for fire safety, literally, and heat and sound. I'll fill like a 2-inch gap between the firewall and the sheet metal with foam for sound deadening, and then do the firewall. So that's how the system works together. If you look at, this is tied into the corner here, and then same thing. You can kind of see over here. This is all tied into the chassis here with landing plates, same way you do a cage. And then that actually ties it into, hard to see right here. That's that bolt we were looking at earlier, where the cross member and the rear chassis X brace mate. So this whole thing works as a system. If you don't do all of it, it doesn't work. Right now, this would taco pretty easily. This is a big rectangle. When you go into a corner, this whole thing would flex. If we didn't have this brace running across here, all the loads that I have now running from the suspension into the chassis, which originally did not do. Remember that bar didn't even exist in the original car. I had to put it there in order to not pass something through the engine. Now I'd have all that load going in the chassis, and there'd be nothing to kind of resist that load. So, suspension load comes through that tube right there, goes over here, ties into this. Obviously, you have this is all structural for crash safety and stiffness. This is all structural. Now this is all structural, and it goes through the whole chassis. So. Now what I haven't shown here is any kind of roll protection. It's not going to be a race car, it's going to be a street car, so who knows. I really don't intend to put a roll cage for sure in it. I don't really want to add that, but because I'm adding a firewall, it's going to cover all this with a window so I can see out the back. I I may do a kind of a roll hoop, if you will. So I may go up at like some 1 3/4, 1 5/8 DOM material and go down and go around. And I'll probably just tie that in with 2 bolt-in braces that go from here to the shock tower. So it won't be X'd, because I already have the X in the middle. And quite frankly, that X won't really do much. It'll be support the hoop from folding over, but straight bars do that fine. Because there's nothing passing from that roll hoop towards the front of the car, the load from that X going up through into there would go nowhere. It'd literally be worthless. So you'll see a bunch of X's in the back and of people's cars, and it's kind of like really a strut tower brace more than anything else. It really doesn't actually stiffen a lot of the car. So I wouldn't bother with that, because already this will be X'd across the engine, which is where it should be, and then we'll just have maybe some down tubes going there. Anyway, so that's kind of it for now. You can see the braces kind of here with the trans mount, but lots of room, should be a lot easier to work on. Again, this is all going to be engine bay. So once I'm done, I'm going to fill all these holes I had to drill out, all the spot welds, factory spot welds. I'll fill all those, repaint this, maybe do like a rhino liner or something like that once I'm sure I'm done, because that would suck to rhino line it and then realize I had to cut something else or do something else. So that's it for kind of walking through the structural stuff that I've done. It's all really simple by itself, but when you look at it all together, it should work really well. The car should be significantly stiffer than it was in the factory. I don't have any tubes in the interior, which is important for me. I don't like that look. And then, you know, I have room for the motor, tons of room. I mean, I can put the engine in here right now. I mean, you see the distance right here between the motor mount and the side of the chassis. It's huge. Here I can put the turbo and a dry sump. The dry sump tank is going to go right there. I can stand with the motor and the manifolds in the car. I can actually stand between the side of the motor and the engine bay. That's how wide a flat 6 is and how tiny the V is. With the turbos mounted down low, you know, the center guide doesn't come up much really at all. The engine weighs the same as the factory motor, so should be very similar handling characteristics, just a ton more power and maybe a little more rear weight bias, because the Lamborghini gearbox actually is quite a bit heavier. And then I'll have intercoolers and some other junk in the trunk. So that's it for structure. Probably my biggest worry at this point is a bunch of stuff to do, obviously, but I'd say one of the biggest things I've got to deal with is cooling system. So I'll talk about that in a later video, what I'm doing for oil cooling, intercooling, water cooling, transmission cooling. Small car, not a lot of frontal area, rear engine, so there's not a lot of airflow back here. Unfortunately, unlike a turbo 997 or whatever, these are barely functional. I mean, these are aftermarkets, they stick out a little bit, but there's no way I'm going to get enough airflow here to really cool anything. Without getting into too much, this is going to handle just airflow for the engine bay, but you got to have an outlet too. So anyway, I'll go over that in the next video. Thanks so much for checking this out. Make sure you subscribe, and lots more cool shit to show you. I'm looking forward to getting this thing done, probably, I don't know, 6 months or so. We'll see. Thanks.